In this video, I'm going to explain some basic circle theorems that you need to memorize or understand how to use them. So the first one is the inscribed angles subtended by the same arc are equal. An inscribed angle is an angle whose vertex is on the circumference of a circle. So all of the three angles here on the first one are inscribed angles because their vertices are all on the circumference of the circle. And subtended by the same arc means that the angles are all made on the same arc. As you can see, the sides of the angles are all on the start and end point of the arc AB. In simpler words, when there are multiple angles that their vertices are on the circumference of the circle and they are all made on the same arc, we can know that the degree of those angles are the same. And now let's look at the second one. So when there is an angle made on the start and end point of the diameter of a circle, the angle is always 90 degrees. Remember, it must be on the start and end point of the diameter. If it's like there is an angle like this, then it's not going to be equal to 90 degrees because it didn't start at the start point and end point of the arc. And let's move to the next one. The central angle is twice any inscribed angle subtended by the same arc. This one is pretty straightforward. The central angle is just an angle with its vertex on the center of a circle. So here will be the vertex, and it's also the center of the circle. And the degree of the central angle will be twice of the inscribed angle if they are made on the same arc. As you can see here, the central angle could also be greater than 180 degrees, and the theorem still works. Now the last one is about cyclic quadrilateral. It is a quadrilateral which has all of the four vertices on the circumference of a circle. And inside a cyclic quadrilateral, the opposite angles are always supplementary with each other, meaning that the opposite angles add up to 180 degrees. So in this case, angle A plus angle C is equal to 180 degrees. And the same for angle B plus angle D is also 180 degrees. And now let's try to solve an exam-style question. This question is asking us to find angle ADC, which I already labeled on the image. We can call it the angle X. And to solve this, we're going to use the third theorem. Angle AOC over here is an central angle, since the vertex is also the center of a circle. And angle ABC, if you notice, is an inscribed angle because the vertex of angle ABC is on the circumference of the circle. So according to the theorem, the inscribed angle is half of the central angle. So here we can know that angle ABC is equal to 168 divided by 2. So angle ABC is equal to 84 degrees. After knowing that angle ABC is 84 degrees, let me just label it on the image. You may notice that there is a cyclic quadrilateral inside this circle. Let me just trace it so it's more clear to see it. There is a cyclic quadrilateral inside this circle because all of the four vertices are on the circumference of the circle. And so we can use the theorem for cyclic quadrilateral. The opposite angles always add up to 180 degrees. So angle ABC plus angle ADC, the angle we're trying to find, should equal to 180 degrees. So we can say that 84 plus x is equal to 180 degrees. And now we just need to solve the equation. So first we minus 84 from both sides, and x is equal to 96 degrees.